Forget to turn on the microphone again. Okay, welcome back to the stream. This time we're gonna continue learning CMake from yesterday. Yeah, so this one is going to be the last part of the learning CMake. Also, the main project I use right now, not using CMake just yet, but for the future might be. And for some case that I might have to like fully support Windows users, I might have to do that. Maybe someone asking about it, and yeah. From the experience from yesterday, CMake seems to have like a more smooth and more flow, easier to use, flexible, clean code, clean configuration, language, syntax, something like that. And even there is the test suite, very simple test suite that you can do simply on top of it. No need to mingle around with the shell script, writing directly into the Makefile. Anyway, my personal preference is that I tend to like to directly use the Makefile because it's like the first thing that I think about it is that Makefile can give you very fast rebuild and retesting the thing that you have. You make some change on the program right away. No need to like remove the build folder, start it over, something like that. Yeah, but it maybe depend on the situation. But for now, okay, let's continue learning this and finishing this. I also have a plan about doing another project. I mean, as part of the game. That this is the project Mason, and I think I'm gonna stream on this as well. Basically, it's like the project that can generate the thumbnail image that you can put on for your YouTube video or maybe social platform video. You live stream, you get it, and you generate the image and put it on the thumbnail image. Yeah, so no need to like open the Photoshop or game to edit that. So this one will allow me to like get to know and be familiar with what should I say, ImGUI, IMGUI, yeah. But this time it's in C, so CMake, yeah. And also you're gonna let me delve down into the OpenGL code as well. So we will see if I didn't finish it before I live stream it, or there's some part I can do it live stream. So we will see. But for now, we continue on the CMake step 5. Yeah, say hello to CL62 too on the Joju. Always send the shark fin back to me. In this section, we will show how you can add a generate source file into the build process of an application. Okay, so this time we're gonna messing around with the generate source file. For this example, we will create a table of pre-compute square roots as part of the build process, and then compile that table into our application. To accomplish this, we will first need a program that will generate a table. In the math function subdirectory, so we go to that math function subdirectory first. In the math function subdirectory, a new source file named maketable.cxx will do just that. Alright, so I'm gonna just follow along. Make table, but in this case it's C. Okay, so this part is one. Make table. Okay, go. Oops. Right. A simple program that builds square table. Include stdio hash. stdlib that hash sharp. Just follow along with this. I'm not going to just copy because maybe some part we can learn about it. even though it's just very simple source code source file. Yeah. Make sure we have enough arguments. If energy less than 2, return 1. Yep, definitely, because square root of 2, no, square root of less than 2, it definitely this is case is 1. Yeah, it's just return things. Okay, open the output file. Oh, so we're gonna write into the file here. Find out f open argv, right? Yeah, I love to use this yeah, if that thing is like something that definitely can be checked with null, I'm not going to use the exclamation point. Okay, create a source file with a table of square root. F print into f out double sqrt table. Okay. Oh, so in this case it's like we try to print the table of square root. It's like a define another variable into a source file, and then it will be there and be at the global state, global scope, and then we can use it in the other source file, main source file here. Okay. Results sqrt static cast double. Okay, so this one compute square root. Printf f out q. Yeah, and we learn about the percent this time percent g. Yeah, we learn about percent g. It's either percent e or percent f. It's gonna use which one depends on the minimum size that it can be. Close the table with a 0. Printf. Yeah, and from now, from today, I refactor the engine code, and I tend to not look at the printf function the same anymore. It's like a printf will directly call fprintf. So to cut the things and slightly a tiny bit increase the performance, I tend to focus on using directly fprintf now and just specify standard error or standard output. But this case is for file, so it's fine as well. Okay, and we're done here. Note that the table is produced as a value 0 plus code, and that the name of the file to write the output to is passed in an argument. The next step is to add the appropriate commands to the math function CMake list file to build the make table executable, and then run it as part of the build process. A few commands I need to accomplish this as so below. So we're gonna make change to CMake list file. Okay. First, we add the executable that generate the table. First, we add the executable that generate the table as executable make table. Let's see. Add the command to generate the source code. Add custom command output versus CMake current binary dir. Table.h. Alright. Oh, so add custom command is something like we send in the command line parameter, I think. Make table CMake current binary dir table.h depends make table. Okay, depends make table. What is this? Well, let's say this. First, the executable for make table is add as any other executable would be add. Then we add a custom command that specifies how to produce table.h by running make table. Next, we have to let CMake know that my square root.cxx depend on the generate file table.h. This is done by adding the generate table.h to the list of source for the library math functions. So this is this line. We also have to add the current binary directory to the list of include directory, so that table.h can be found and included by MySQL. When this project is built, it will first build the make table executable. It will then run make table to produce table.h. Yep. Finally, it will compile MySQL root.cxx, which includes table.h to produce the math function library. Finally, it will compile MySQL root.cxx, which includes table.h. Okay. At this point, the top level of file with all the features we have add looks like one. Okay, I'm gonna research more about the add command here. Add the custom build rule to generate build system. There are two main signatures for adding. The first one is adding command to produce output. This is find the command to generate output file, a target created in the same directory. That specifies any output of the custom command at the source is given the rule to generate the file using the command at build time. Do not list the output in more than one independent target that may build in parallel, or the two instances of the rule may conflict. Instead, use add custom target to drive the command and make the other target depend on that one. If an output name is relative part, it will be entropy relative to the build tree directory correspond to the current source directory. Note that main dependency is completely optional and is used as a suggestion to Visual Studio about where to hang the constructor. In make file terms, this create a new target in program. Okay, if more than one command is specified, there will be executed in order. The optional arguments is the backward compatibility, and it will be ignored. The second signature add a custom command to the target as the library or executable. This is useful for performing operation before and after. Depend, I just want to know depends. Okay, if append is specified the command and depend option value are append to the custom command for the first output specified. There must have already been a previous call to this command with the same output. The command working directory and main dependency option are currently ignored when append. The depends option specifies files on which the command depends. Okay, so this command depends on such a make table executable, I think. If any dependency is an output of another custom command in the same directory, CMake will bring the other custom command to the target in which this command is built. It depends is not specified. The command will run. The command will run whenever it puts. Okay, so no need to go through that much detail, I think. So this command depends on this makefile to have. And what about the output? Let's see. This define command to trace this my output file. This is my output file. Alright. If any dependency is an output of another custom command in the same directory, not quite so sure about the output command here. Add the binary tree directory to the search part. To the search part for input files. CMake current binary the add the main library. Oops. Map functions mysqrt, let's see, and CMake current binary the table reference. Okay, so we done at this point for the math functions. CMake list file. Move on to the top level of CMake list. Project. Not this one. function. Then we go back to unit. CMake list. Okay. And let's see what we got here. Add the install target. Have you done it already? At this point, the top level of file with the feature we have looks like the code. Okay. So you might have to like explicitly include functionality that it needs. So we have test case as well, so include T-test. Let's config. Right. It's okay now. What about CMake list? Okay, seems we may try to execute it. Build CMake. Slightly complicated now. Okay. I might have to maybe I should change this back now. Add executable. Add custom command. Let's try it again. Go. Notable C. Notable C 28. Static cache. Exo expression. Oh, I guess it's nothing like this. Yeah. Okay, I found this. C++ style cast unchecked by the compiler. C style cast on and can fail at runtime. Also, small style cast can be searched for easily. Where it's very hard to search for C style cache. Another big benefit is that the 4 differences in the cache rate and send and the remote code. The main reason is that the classic CMake make no distinction between what we call. These 4 things are completely different. A static cache is usually safe. There's value conversion in the language or accurate conversion to make it possible. The only time it's really risky is when you cache down to an inventory crash. You must make sure that the object is actually the descendant that you claim it. By means external to the language, like a flag in the object, a dynamic cache is safe as long as the result is checked pointer or possible exception is taken into account. Reinterpret cache or cons cache, on the other hand, is always dangerous. You tell the compiler, trust me, I know this doesn't look like a fool. This look at it is not mutable, but it is. The first problem is that it's almost impossible to tell which one will occur in the C star cache without looking at the last in this first piece of code and knowing other rules. Let's assume this. Same as with the plate. Yes. Same as that case. Okay. Now these two are compiled the same way. Save as long as we check. Same as static cache. Save as long as we check. But what is this? But harder to read. However, let's see this almost identical code. Compiler error can convert. No compiler error. Same as reinterpret cache. What is this? That is wrong. As you can see, there is no easy way to distinguish between the two situations without knowing a lot about all the class involved. The second problem is that the C-style cache are too hard to locate. In complex expressions, it can be very hard to see C-style cache. It is virtually impossible to write an automated tool that needs to locate C-style cache. For example, a search tool without a full bullshit plus compiler front end. On the other hand, it's easy to search for static cache. Okay, yeah, there's nothing here like this one. You see, so just cast normally. Double. Let's try that again. Okay, for now, let's see what we got. Let's see map function. Yeah, we got table now. So this is our table. Generate in runtime. No, generate in build time. Where does CMake? Quite cool. Custom rule. Yeah, so for the map function target, add executable make table in order to generate the table that you see already in the header file is generated, and apply the command argument here. This is the file that we're going to write into depends make. Quite useful if you have to do a dynamic stuff. Add the main library. Okay, this is just to let my square root C know about it. Maybe we modify the table, square root table. I'm gonna try to include table.h as well. Okay. Play around with this a little bit. And I'm gonna print square root tables for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I'm gonna print it. Element add d double is LF, I think. Specifier. Yeah, for double is RF, and yeah, let's see, make it again. Okay. And now I can execute this. Make print. Scanning dependency of that functions. Hey, thank you for sharing the link. Thank you so much, 1, 2, 3. This doesn't execute just yet. Use X. Okay, I'm gonna disable using exponential and also log function. So it's gonna execute here. I should go back to this. Log. That function exists. Nope, I'm gonna just comment it out. do it again. Where is this one? Make clean first. Make. Tutorial. Oh. I believe it doesn't. We need to remove it. Okay, start it over. Okay, make. Now it's that is. So it's print the square root table now. Because it's just a part of the build process that we check. The main source file, what is this? Tutorial.c, okay. Tutorial.c. Yeah, as you can see here, we have block and also have exponential here. So we disable that, so it's not going to enter this case, it's going to enter this case instead. And use my math is on, so it's gonna include our math function.h, in which case it's gonna execute our my square root function here and print our table. So yeah, okay, so we can dynamically disable, enable the functionality when we build the program. Good. Okay. We can move on to step 6 now. Next, suppose that we want to distribute our project to other people so that they can use it. We want to provide both binary and source distributions on a variety of platforms. This is a little different from the install we did previously in the section installing and testing, where we were installing the binary that we had built from the source code. In this example, we will be building installation package that support binary installations and package management features as found in CMake, Debian RPMs, etc. To accomplish this, we will use CPack to create platform-specific installers as described in chapter Packaging with CPack. Okay. Specifically, we need to add the field line to the bottom of our top-level CMake list here. Add a field line to the bottom. Okay. Driver installer package. Okay, it's include install. What is this? Require install require system libraries. Set CPack resource file license and CMake current source the license.txt and okay, CPack package version measure tutorial. Okay, this is the same major and minor version that we define at the top of the file. Version major. Okay. Yes, good one. CPack package version minor. The same goes tutorial version minor and include CPack. Okay, this is all there to it. We start by including install required system libraries. This module will include any runtime libraries that are needed by the project for the current platform. Next, we set some CPack variables to where we have stored the license and version information for this project. The version information makes use of the variable we set earlier in this tutorial. Finally, we include the CPAC module in which we use this variable and some other properties of the system you are on to set up and install it. The next step is to build the project in the usual manner and then run CPAC on it. To build binary distribution, you would run. Alright. Let's us do it again. I'm gonna remove build. Okay. And call CMake. CPAC config CMake. Okay, so now CPAC config CMake is generated now. Let's pick it, the file a little bit. What is inside? CPAC config. Okay, so inside. Version thing in the stuff. CPAC name. Okay. Sysload. Anything's there. Measure. Okay, so measure and manual version is there. Hello to Kai. Welcome back, man. How are you? CPAC configs. Yeah, we have CPAC config already, and let's just try to do it. Run pre-install target for blah blah blah. Will you also go back to your hometown? Dukai. I hope you have the ticket. It's so hard to like a fight with other people to get a ticket. Problem running install command. Please check. It's not super duper priority for me to get this kind of thing. CPAC. No rule to make target pre-install. Ooh. CPAC source config. CMake. Okay, so CPAC source config is generate the source file like a tarball here. Also tar.dsat, tar.bsat, something like that. So it's fine for the source distribution. But for binary distribution, it's weird that I cannot run it. Cannot run it. Will generate packet tutorial. Oh, no target file and no make file for. What happened here? There's no make file. Okay. Okay, start over. I think this is weird. Go to build and CMake again. And Oracle. Okay, Oracle. Install required system release. Oh, install. Hey, sister. Welcome back, man. I noticed you. Ni hao. I hope you all people that come on Dojo have a ticket reserved and can go back to your hometown soon. Yeah, I'm gonna go back next month, early next month. Actually, not my hometown, my girlfriend's hometown. Yeah, I miss it. I miss the things here. Install required system library. I miss the typo a little bit. I'm gonna start it again. License take not file. Oh, definitely. All right. yeah. But I think it's not. Might not be the case because this one. Yeah, I'm aware that I don't have the license tag just yet. Oh yeah. Okay, I'm gonna just. You're right. I'm gonna create the license here. Thank you for that, Jakai. Echo, do what you want with it. Okay. Can I just go license. CMake current source there. Right. Yeah. Okay, so things fine now. I'm gonna try to create the binary distribution again with cpath config. cpath config.cmake. Alright. So in this case, create for Mac OS platform only because this is Darwin. Yeah, you can check it. We are here. uname.s and it's Darwin. It's actually right. I'm gonna try to take a look inside tar.gz here. I'm gonna copy it to somewhere first because I'm not sure if I extract it here it's going to be messed around in my build folder or not. Oh, I can do it something like yeah, temp, and then I copy it. Tutorial 1 Darwin tar to my temp. Okay, I'm gonna extract it. Let's see what inside. Okay, so it's organized in the proper directory name, so it's good. Bin include libs. Cool. So it's also organized header file for us as well. I just have and another one is just mat function.h and that's it. Good. Okay, right now I imagine that if I write directly to make file, I have to do bunch of things and write bunch of like a shell bash script code in order to generate and push the distribution in the include folder, generate the binary executable and put into the bin file. So I think it's going to be a lot of work there. And I know I'm late to like the C++ ecosystem low native. I just switched from the mobile stuff several months ago, and I saw a lot of people that used CMake in their build step. The great example is that a Sprite here. A Sprite is based on C++, and a lot of like indie game dev out there use it, build it yourself, and then you can. Yeah, I just noticed CMake list here, and boom, seems to be a lot cleaner as well. I mean, a lot cleaner in terms of like a configuration. So it uses a lot of like an open source library out there, depend on things. Benchmark. Yeah, I think we can learn a lot from other projects that based on the CMake as well. Yeah, Steam folder. So what I love about CMake, another part is that you can organize into the directories here, and then inside there you just create the CMake list, and this CMake list is going to build that whole folder for into object file, library, static file, something like that. So in this case, add libraries, yeah, and link with the lab base link flat here, so it's good. Yeah, quite handy. Yeah, anyway, I'm coming from the make file, so I get used to the write the things manually. Okay, let's check it. Lib mat functions is here. So oh. Oh. Can I make clean? Okay. What is limo plus CMake? One downside is that CMake doesn't have CMake clean or something like that. Okay, and the last step, I'm not going to do it because it's just add the build status back to their own service public dashboard in order to like let you know the build step, like a CI or something like that. C dash here. Okay. I'm not going to do that. No need for me right now. Okay, yeah, and that's it, I think. Yeah, this stream going to be short because I plan to just finish the CMake, and then hopefully next stream I going to I plan already. I plan about making a simple project that will use this one. Yeah, CMake. Yeah, it's a C implementation for very popular project CMake. I am GUI. Yeah, this one. So it's like a immediate mode to have UI on top of your application, and I use SDL too, so it can be used with this as well. I have a base project that work with this as well already. So what I'm gonna create is that I'm gonna create this one, mash on a simple project that will allow the opportunity for me to create have a chance to work with these two things, CMake and OpenGL a little bit, to create a thumbnail for your YouTube video, or yeah, Dojo when you have live stream and you set with that video, you post on somewhere else and you have a thumbnail. Yeah, so you can set background, you can set text, and you can select which TTF font you wanna have, and which color is that, and what is the brightness for the background, something like that. So make it automate, and I don't have to open GIMP or Photoshop to edit the file, something like that. So hopefully next time we're gonna do that. Okay, and that's it for now, I think. Thank you everyone for coming today. A little bit short, 1 hour, more than 1 hour, a little bit. Yeah, 1 hour. Okay, so see you next time. And thank you to Kai and Priest Sister for coming as well, and other people too, Cell62 on Dojo. See you next time. Okay, bye bye.